How can we say that an object is hot or cold? Our senses provide us with indication of temperature, by telling that the pan is hot or the water is cold when added with ice. However, our senses are unreliable and often mislead us. We cannot give exact measurement of temperature by saying hot or cold. What we need is a reliable method for measuring the relative hotness or coldness of objects. Instruments designed to measure temperature are called thermometers. It is defined by numerical scales, commonly Celsius, Fahrenheit, and Kelvin as SI unit for scientific works. To understand the concept of temperature, it is useful to define two often used phrases: thermal contact and thermal equilibrium. Thermal contact is when there is energy exchanged by two objects of different temperature. Thermal equilibrium is when two objects are in thermal contact and there is no exchange in energy, and both objects are at the same temperature. This leads to the statement known as Zeroth Law of Thermodynamics. This means, if objects A and B are separately in thermal equilibrium with a third object C, then A and B are also in thermal equilibrium. The concept of ideal gas law might come in handy in physics, since it also deals with physical properties such as temperature, pressure, and number of gases presented as moles. This law is actually a collaborative idea of several scientists postulated and theorized the relationship between the properties of an ideal gas. Ideal gas approximations works for certain temperature and pressure ranges, and assumes that either of these variables are constant. Thus, it is safe to use the ideal gas equation to solve many gas problems. Boyle's law states that volume is inversely proportional to pressure, at constant temperature and number of moles. Charles's law states that the volume is proportional to the temperature at constant pressure and number of moles. Avogadro's law is when volume is proportional to the number of moles, at constant pressure and temperature. Amonton's law is when pressure is directly proportional to the temperature, when volume is kept constant. Combining all these ideas, leads to the famous formula, PV is equal to nRT, where R is the proportionality constant, or the gas constant. Thermodynamics is the study of heat and work, and is very important in physics and engineering application, specifically for engines. We already know that heat is a transfer of energy due to temperature differences, while work is a transfer of energy by mechanical means, not due to temperature differences. These variables play important roles in defining the first law of thermodynamics, which is basically the statement for energy conservation. The amount of energy in the universe is constant. This means that energy is merely changing from one form to another, and can never be destroyed. The internal energy, delta U, is equal to the heat Q added to the system, minus the net work W done by the system. This is the sign convention for heat and work. Example: 2,500 joules of heat is added to a system, and 1,800 joules is done on the system. The internal energy of a system is equal to 2,500 joules minus negative 1,800 joules. Since work is done on the system, it must be negative. Internal energy is equal to 4,300 J. There are several thermodynamic processes of an ideal gas, when dealing with thermodynamic problems in physics and chemistry. Isothermal process, from the Greek meaning, same temperature, is carried out at constant temperature. From the ideal gas law, PV is equal to nRT, since temperature is constant, it must be PV is equal to constant, and the PV diagram look like this. Take note that in this process the internal energy is zero. The change in temperature is zero because the temperature is constant, it does not change. So, it leads us to heat is equal to work. An adiabatic process is when no heat is allowed to flow in or out the system. Thus, the internal energy is equal to negative work. Comparing it with isothermal process shown in the diagram. Isobaric process is when pressure is kept constant, and thus it is represented by straight horizontal line. Isochoric or isovolumetric is one which volume does not change and represented by this PV diagram. In this process, work is zero. From the formula, work is equal to pressure times change in volume. Work, in physics, it is something that is accomplished when force acts on an object, and the object moves through a distance. Converting this definition into a formula, work is equal to force times distance. Same concept is used when dealing with work in thermodynamics. Pressure is equal to force divided by area, and so force is equal to pressure times area. Substitute this to the work formula, work is now equal to pressure times area times distance. Area times distance is simply equal to the change in volume. Now, work is equal to pressure times change in volume. Pressure is constant, while the volume changes when work is done during a thermodynamic process, isothermal process. Sometimes, it confuses students why there are two different sign convention used in physics and physical chemistry, in thermodynamics. This does not change the actual law of nature, it's a matter of reference points. In physics, work is negative when work is done on the system. This is because, it refers to one who does work on the system, which is the outside of the system, or the surrounding. That's why work is negative, because energy is released by the surrounding to the system.